This is a oral history interview for the archives at the University of Alabama in Huntsville. Today is December 13th, 2013. I'm Charles Lundquist. Our guest today is Rein. Rein, it's a delight to have you here today. Thank you for coming. We like to start out by letting the interviewee tell a little bit about their childhood, where they were born, and sort of work their way up to where they went to school.
All right. Well, it's certainly my pleasure to be here.
Thank you.
And I know I've been putting you off for some time, but finally we can talk about the many years that I spent here at the Marshall Center and in Huntsville, enjoying my career in the space business. Well, I started out 78 years ago in a place called Tallinn, Estonia. That's where I was born, and this was before the Second World War, and we lived there where I started my elementary school training, which was then interrupted by the Second World War. The Russians, the communists came into the Estonian nation, took it over, which was a very sad time for the Estonians because of the oppression of the communist scheme. And then the war carried on, and the Germans came in. That again was not really a pleasant time, but it turned out that Germans were somewhat more friendly towards the Estonians than the Russians were. And then when the Germans started losing the Second World War, my parents decided to not stay there because of the communist type of the communist regime, and they were able to go to Germany, where I spent 4 years in a displaced persons camp. We continued our education there, elementary education, and then...
Did you learn German?
I did learn some German reasonably well. We lived in the German community, from 44 to 48, 4 years. So yes, I picked up quite a bit of German, which unfortunately I've forgotten a lot of. But then, of course, the Germans lost the war, and we were in southern Germany in a displaced persons camp. And then my father had a connection in the United States and was able to get a guarantee of a job in Baltimore, Maryland. And we moved to Baltimore, Maryland in 1948, where I then continued my education, which was kind of interesting because at that point in time I had only had 3 years maybe or maybe 4 years of elementary school education, and they put me into the 9th grade in Baltimore.
That's a bit of a jump.
That was a bit of a jump, particularly we were also changing languages.
Yes.
I had learned some English in the German in the school during our stay in Germany, but my English was rather poor. But we moved into a home where there was a young man who I befriended, and that's where I really started learning my English.
That's the way. That's the way to do it.
Right, and of course at that age I was 13 then when we moved to Baltimore, and at that age those things come to you fairly quickly.
Yes.
So I went to junior high school and to a technical high school, and then was admitted to the Johns Hopkins University in Baltimore, which besides having a very well-known medical program also has all engineering and other
it's a very good school for those things.
So at that time it was, it still is a fairly small school compared to others, but anyway, I went to Johns Hopkins and received my bachelor's degree in engineering science, which they had come up with that title, which gave us a little bit broader background, not so much of a specialization. I was already at that time interested in spaceflight. I had read some articles in, I believe it was Collier magazine that Dr. von Braun had published.
Those are famous articles.
Right, and so that caught my eye, But what really, now that I think back, what really got me into the space program was the fact that I enrolled in the ROTC program, of all things. I had no idea where that would really take me, but after I graduated from Johns Hopkins, I went to work for Pratt & Whitney because I was interested in propulsion specifically already at that point. I was a mechanical engineer, really, and that was my interest. For something electrical engineering that gave me trouble. But anyway, I enrolled in the ROTC program, and after I graduated, they called me into active service. And after I had finished my basic training, I had a choice of where to go for my 2 years of active duty commitment. So I put into that form that I was interested in propulsion and rockets. And lo and behold, somebody in the Pentagon recognized that and gave me an assignment to go to the Army Ballistic Missile Agency in Huntsville, Alabama.
What year was that?
This was in 1958.
58, all right.
I'm sorry, no, 1956.
56.
That was 56 when I graduated from Johns
ABMA
Hopkins.
was set up in 56.
ABM was set up.
So you got there right at the beginning.
Exactly. They were just building up. They were looking for military staffing as well as civilian staffing, and they were interested in bringing in young officers who had some interest or education in the area that could help them. So
there you were.
There I was. I was at Aberdeen, Maryland at the time when I finished the basic training, and I said, I'm going to Redstone Arsenal. Does anybody know where Redstone Arsenal? Nobody knew where Redstone Arsenal was.
Oh, really?
Nobody, not back in 1956. Finally, one of the military people said, I think it's in North Alabama. So I said, well, okay. I couldn't find Huntsville either or Redstone Arsenal on the maps at that time. So I got in my car and started driving what was then Highway 11. Of course, that was before any interstates or anything.
Yes.
It took me almost 2 days to get down here. And I said, well, I see there's Chattanooga. That's near North Alabama. So maybe I can find some road signs in Chattanooga. And sure enough, that's what happened. I got to Chattanooga. There was an arrow pointed to Huntsville. I drove to Huntsville. In Huntsville, they had an arrow that said Redstone Arsenal, and I went to Redstone Arsenal, and there I was in the Army Ballistic Missile Agency.
So that was in the very early days when Medeiros had just taken over.
This is correct. Yeah.
Did you meet him immediately?
I never personally met Medeiros. Of course, I saw him because we were all in the same building. But my assignment that time was in the industrial division of ABMA, where they were starting to plan the deployment of the Redstone and Jupiter missiles.
Mm-hmm.
The Redstone missile was already essentially developed at that time. They were still doing test flights at the Cape. And the Jupiter was just being thought of because they were looking for a longer range.
Well, that was the thing that got ABMA set up, was the assignment to do the Jupiter.
That's right.
So you got there just at the beginning of that.
That's right. And there, obviously interesting projects, but in the industrial operations division, the assignment was to prepare for deployment, which means I was given all kinds of assignment of ordering trucks and tents and covers and all kinds of supporting equipment for them.
Good mechanical engineering.
That's right.
job.
So
yeah.
anyway, I was busy doing that. And of course, the initial Redstones were built in Huntsville, as well as the Jupiters. But then they phased in the Chrysler Corporation, their plant in Detroit, Michigan, in order to fabricate the large numbers of missiles that were required for the military application. So that brought me more into the engineering field, because now we had to start working with a contractor and coordinating engineering issues, test results, and so forth. And so I ended up with quite a few trips to Detroit and working with the engineering staff at the Chrysler Corporation. Well, that was all very interesting, but what really was exciting was that the Russians put up the first satellite, Sputnik, which you can imagine had a tremendous effect on the thinking and the excitement here in Huntsville. Of course, in the meantime, Dr. Von Braun, who was the head of the development operations division under ABMA, had already been thinking in this area and had prepared, that the team had prepared an extended version of the Redstone missile that was capable of putting a small satellite into orbit. That was done in conjunction with the Jet Propulsion Lab, who provided the solid rocket upper stages. The effort here in Huntsville was, of course, coordinating with JPL, doing some of the testing. I remember very clearly going to one of the test buildings and where they were doing the dynamic testing of the upper stage, the solid rocket thing, which was spinning in order to provide its stability once it was launched into orbit. So all of that, of course, was exciting that now the Russians had done that, and the ABMA, the Army, was given the assignment finally. They'd been storing the equipment in the meantime because they were told not to launch anything in orbit because that was a political mistake, according to the administration.
Yes.
And so they stored the equipment, and when the Russians put their satellite into orbit, then they got the order to put also a U.S. satellite.
Actually, after they put a second one in orbit.
Oh yeah, that's correct. By the time we were actually able to get that, it took about 3 months to get from the storage condition to the launch condition. In those 3 months, the second Russian satellite was put in orbit. That's correct.
Yeah. Well, the authorization to do the launch didn't come till after.
Oh, is that right? Okay, I didn't know that exactly.
Yeah, that.
But
right,
anyway,
right after the second one.
But of course, then you can imagine the positive reaction, the excitement when the United States finally, with the ABMA putting that first satellite, the Explorer 1, into orbit. And of course, there were other satellites that followed. That was Explorer 2, Explorer 3. There was in the meantime, the Jupiter system was being developed, and also a version with an upper stage, the same upper stage, I believe, as on the Explorer.
Yes.
To put a probe into interplanetary space,
yes,
not just into Earth orbit. So that was the Juno 1 mission?
Yeah.
I believe it was Juno 1 mission. Anyway, so
you were still in the Army?
I was just finishing up my Army assignment 2 years, and I was trying to decide, well, this is all very nice, but you know, this seemed to be still a little bit sort of distant and foreign to me, whereas the business with Pratt & Whitney of working on jet engines, you know, so
How long had you been at Pratt & Whitney before you went in?
I was only at Pratt & Whitney 6 weeks.
Oh, really? Okay.
When the Army called me.
So you hadn't got very deeply into it
That's
yet.
right.
All right.
Right. So I thought I'd go back there, but here's another incident, you know, just like this business of getting the assignment from the Pentagon to come to APMA. The incident was that I've contacted Pratt & Whitney about coming back to work for them. I never got an answer.
Really?
Never got an answer. And I said, well, you know, somebody is giving me a message. And in the meantime, I had also met Bob Lindstrom, who was the manager of the project office then, that had started working on a Saturn concept with clustered Redstone engine, Redstone boosters.
Mm-hmm.
And Bob Lindstrom got a hold of me and said, hey, I'd like you to come to work for me, because he was building his office up, and that whole operation was starting.
And you knew about the Redstone production from your work with Chrysler.
Right.
Very good.
So I said, well, this looks like a good opportunity. And I then agreed to stay here, and I was given I was in the project office and given one of my first jobs was to develop a project plan for the Saturn 1, the the demonstration of clustered propulsion.
Mm-hmm.
And so I developed the project plan, and then at that time there was no obvious use yet for Saturn 1, so they asked me to do a brochure that provided all of the capabilities of the Saturn 1 so that could be distributed, and then potential users could maybe make orders of this.
Yes.
Well, that's not exactly how it worked out, but anyway,
Yeah,
that was the assignment.
Interesting thing
That's
to
right.
do anyway.
So here I was working on the Saturn 1 program very closely with the German team. Of course, one of the things that I will never forget is when I first met Dr. von Braun. I had just went to work, I think, for Bob Lindstrom, and I decided, well, Huntsville at that time was a very small community.
You didn't meet him while you were with the Army then?
Not really.
Okay.
No, not really. Well, I don't know. You know, this is over 50 years ago.
All right.
It may have been during my last.
I shouldn't
As a matter of
push
fact,
you
you're
to it.
right. I was still in the Army there towards the end. Huntsville was a small place. Not a whole lot of things to do here at that time for a bachelor.
Uh-huh.
And so I read about the Astronomical Society that had a observatory up
Yes.
in Montesano. And I said, well, I'd like to go up there, and that sounds like it might be an interesting thing to do. So I called up Dr. von Braun's office, and Bonnie Mueller, who was his secretary at the time, answered, and I said, well, I said, do you have any information? All I was looking for was a brochure or something on information. And she said, oh, well, come on up here at 2 o'clock. And I said, okay, I'll be there at 2 o'clock. I went there at 2 o'clock, and I was expecting her to give me a brochure or something. She led me into Dr. von Braun's office.
How nice.
I couldn't believe it. Not only that, but he said, well, you know, he had asked me to sit down. He spent 30 minutes with me, asking me about my background, you know, my experiences. Just a wonderful conversation with a man. And of course,
He was like that all the time.
yes, he was just a wonderful individual, personality, you know, in personal contact. And so I was just totally impressed by that. So that's just one of those memories that just never go away. And also, like I say, in my mind, I don't care what they wrote about Dr. von Braun in various publications, but he was just a very fine person as far as I'm personally concerned. And my contacts with him, and during my career, of course, made a lot of presentations where he was the main audience, and he never gave me a hard time or embarrassed me. He may correct me at times, you know, or
And
ask
he always
questions.
had questions.
He always had questions, but it was just a very pleasant interaction for me. Okay, so the Saturn 1 program was on its way, and I decided, well, you know, I've always looked for an advanced degree, so I made contact at one time Dr. Zucrow, who was the head of the propulsion laboratory at Purdue University. And I said, you know, I'd be interested in getting an advanced degree. And he said, oh yeah, come on, you know, at Purdue. So I left, I got a sabbatical basically from the Army, and went to Purdue for 1 year to get my
This was
master's
after
degree.
you were discharged, though, from the, or were you?
I was discharged already.
Yeah.
Yes, I was a civilian.
Yeah, okay.
And
You went under the civilian training
right,
program.
civilian Army program. That's
Yeah,
right.
all right.
So I went to Purdue for a year, and lo and behold, this was in entered Purdue in the fall of 1960, and for 1 year. Well, Marshall NASA was established formally out of the Development Operations Division headed by Dr. von Braun. while I was at Purdue. Well, I finished Purdue, received my master's degree in specializing in propulsion, and came back. Well, Saturn I was well on the way, but they had just started thinking about the Saturn V. It didn't really have a mission yet at that time, but Dr. von Braun and in collaboration with ARPA, the Army Research Project Agency, wanted to see a demonstration of a large booster rocket.
Yes.
It reminds me a little bit of what's going on today.
Yes, it's very
so
reminiscent of that.
Right. So there was no mission for it, but the development of the Saturn V was just beginning. So I said, hey, this is a really fine opportunity also, and I joined the project office, which at that time consisted of 5 people, I think. I believe it was 5 people, and I became, I think, the 6th person in the project office.
Who were the first 5?
Fellow that was heading, from a project office point of view, heading the Saturn V activities at the very beginning was a fellow by the name of Jim Bramlett. Mm-hmm. Jim Bramlett, a really fine guy, but he had the program had just started, and it was still kind of on the back burner, and he and myself and some of the other fellows were just starting the planning and the establishing the requirements and all those kind of things and coordinating that kind of activity. So as the and he gave me responsibility specifically for systems engineering, which involved establishing the overall system specifications, working interfaces, and so forth. So he of course continued hiring people, and the program started growing. The program got an official go-ahead, and with that, of course, bringing in major contractors to do the heavy lifting, so to speak.
Surely.
Boeing on the Saturn on the first stage, North American Aviation on the second stage, McDonnell Douglas on the third stage, and of course the project office grew accordingly, and each one of the stages now had their own sub-project office, and the whole activity became so large that they brought in Dr. Rudolph to head that activity. I was involved in the very front end of that program, and some of the things that were established were new to all of us, and we had quite a job at that point in implementing things like, for example, configuration management. Configuration management was not known within NASA at that time, at least the Marshall Center, and that was brought in to formalize these rather difficult interfaces between all of these systems, both internal to a stage as well as between stages. So configuration management working groups were working groups organized by discipline. These working groups, the assignment to these working groups, of course, was to work interfaces and coordinate all of the engineering activities so that there was real cohesion in the total system. Again,
Sort of the team concept that von Braun always pushed.
right, and it worked really well. I mean, at that time, when decisions were made, they were made by either individuals or usually very small groups. It wasn't one of these things where a large number of people became involved, or you sent everything to some kind of a study group and so forth. Unfortunately now, there's too much, I think, of that. Things were done, in my opinion at least, more efficiently back then. Now, it may not have been just as perfect maybe as it is today, but things got done a lot quicker and cheaper because of that. Anyway, another one of these memories that just will never leave me is one of the last acts that I had under the Saturn V program. They gave me an assignment to present to Dr. Miller, who was then the head of the Apollo program in Washington.
So by then the presidential directives to go to the moon had been announced.
Yes. This was after the assignment to do the lunar mission and to do it before the end of 1969.
Which really built a fire under the whole organization.
Oh yeah. But anyway, so yeah, that decision had been made, and I was given the assignment of providing a presentation to Dr. Miller of what the development program of Saturn V should consist of before the astronauts are, in order for it to be man qualified.
Mm-hmm.
All right, and so we worked that with all of the key senior people here, and came up with a program where we recommended that we do 3 first stage flights, 3 second, then adding the second stage, do 3 flights like that, and then add a third stage and do the third, do the full up flight, so to speak, which would be the 9th flight, and then after that we would declare that it's ready for the manned mission. Well, this was in 1964, I believe. Yes, 64 is when I made that presentation.
Sounds about right, yeah.
He and his staff from Washington came down here, and I, one of the junior staffers, stood up there with the flip charts,
yeah.
And I started going through this presentation, giving him all kinds of great rationale why that should be done. Well, of course, we were basing it on the fact that the team, the Von Braun team, of course, had been doing a number of flights of the Redstone, a number of flights of the Jupiter, a number of flights of the Saturn I in order to work out all the bugs.
Yeah, that
so
was
it
the
made,
way it worked.
Yeah, it made sense then that you'd ought to do a similar thing.
Yeah.
Well, I'm standing up there giving the presentation, and about halfway through it, Dr. Miller said, "Look, I appreciate all this, but we're running out of time. Why don't you sit down?" You know, and after all this work, I felt like maybe, gosh, did I do something wrong? But anyway, he was very nice about it. I sat down. He said, "Here's what we're going to do. Yeah, we're going to go all up." Big old all-up decision that Dr. Miller made. We're going to put all 3 stages together, and we're going to launch that. And if there are problems, then we'll do a second one. But if everything goes well and we're ready to do the next mission, we'll do 2 of those missions and then put the man on the 3rd mission. Dr. Von Braun and the team sat there and they were just shaking their head. They didn't believe something like that would really work, because this complex system is going to have some problems. So you really more launches than that. But Dr. Miller was right in that. Now that thinking back at this, if there had been a problem, sure, you'll have additional missions. But if you're successful or almost successful, then there's no reason to just proceed. And that was the only way, really, and as far as the schedule was concerned, that one could meet the deadline of launching before 1969.
Now, Miller was a wise man.
Well, yes, he was. He was a very, very, very good director of the Apollo program. But it wasn't really an original idea on his part, I found out later. He had been working on a Minuteman system for the Air Force. And I don't know whose idea it was within the Minuteman thing, but they applied that principle in Minuteman, and so he carried that over.
I hadn't heard that story.
Yes.
That's an interesting bit of history.
So but he may have been the originator of that on Minuteman too, but I don't know. It actually came from the Minuteman.
Okay, that's an interesting bit of history that we're getting here.
Right. So anyway. I somehow survived that little episode, and it's always been ingrained on my mind. I guess the lesson there is, even though you know, you feel like you've been chastised in a way, because the rest of the Von Braun, the rest of the team, you know, they didn't take up the arms for me. They sort of said, you know, well, yeah, that guy, you know. Where did he come up with this idea anyway? So
that's good.
Yeah. So anyway, if you just, you know, in this business, if you just relax and say, now look, yeah, this is the part of the learning process.
Yeah,
we'll
right.
go on from there. That's the way to do it. You know?
It surely is.
Don't take it to heart that much.
Surely is.
Anyway, so shortly after that presentation, Dr. Miller, I decided there was an opportunity to go on to interplanetary space missions. There was an idea to launch, to build a Jupiter C. I'm sorry, Saturn 1C. Saturn 1C. Saturn 1C, which consisted of the Saturn 1 with a liquid hydrogen second stage with that was capable. Well, anyway, the combination of the stages was capable of putting the Viking. I think it was the Viking payload, sending that to Mars, doing one of those missions. So that sounded very interesting. So I decided to leave Saturn V and start working on that. Well, that program didn't last very long. They decided that they could do it with one of the adaptations of the, I believe it was the Atlas that launched,
I guess it
launched the Viking. So we dropped that, but at the same, just about the same time, Dr. Miller had been pushing for a follow-on program to the Apollo, because he felt the team was built up, the capabilities were there. He felt like the Saturn V could do a whole series of missions on the moon, as well as maybe prepare even for a Mars mission. So what he was pushing was the Skylab program as part of that follow-on activity, to build a space station in orbit. And so I became part of the Skylab program, and one of the key elements of the Skylab program as it developed was a solar observatory called the Apollo Telescope Mount.
Who was the first manager of the Skylab program?
The first manager of the Skylab program was Lee Ballou.
Okay, so he kept on during the whole program.
Lee was he was it for the whole program. He had originally during the Saturn V development, he'd been responsible for the rocket engine programs that Saturn V used. And then when Skylab was established, he was moved over from that over to the Skylab program and was given responsibility for Skylab. So I became one of his sub-project managers on the Apollo Telescope Mount. And one of the interesting things about the Apollo Telescope Mount was, of course, that it was a purely science mission. Although Marshall had been involved in other science missions, for example, like Explorer 1 and others, this was the first major science mission that was done by Marshall, and the payload itself was done as an in-house project. So it was a very new experience and a very broadened experience for the Marshall team. So the Skylab mission, Skylab activity involved, well, of course, the ATM that I was manager of, and then Marshall was also responsible for the workshop part, which again was a unique experience and a new experience because this involved now developing habitation systems for the crew within the workshop, which originally was conceived as a dry workshop that was to be built up into a crew quarters in orbit, and then the decision was made that would be too difficult, and the decision was made to outfit the whole workshop on the ground and launched. Well, ATM was part of that whole complex. It was deployed from the side of the workshop, and originally, of course, all the ATM assignment was to only do solar science. There was 8 solar telescopes on board, and with of course advanced resolutions of in the various spectral regions of solar activity, and it was not asked to do anything originally as far as the overall Skylab was concerned. But as the Skylab program developed, ATM was also given responsibility for maintaining the attitude of Skylab, and also provide a certain amount of the solar, of the electrical energy by virtue of the solar arrays that the ATM had. So ATM became much more involved in the overall system, and the job grew and the project grew into a much larger effort than originally conceived. Well, Skylab was a wonderful program, and again, it was, for me, it was really another milestone in that I was able to go through that program from the very beginning when it was conceived till it was successfully launched. And
that's rare these days.
It is very rare, and it's just one of the more enjoyable things about, I guess, on any effort, where you can start from the very beginning and finish it up and see what you have accomplished.
Right.
As a matter of fact, after the mission was flown successfully, well, I don't know how much other people, I'm sure, have talked about this, but Skylab itself, of course, had problems. During launch, one of the workshop solar arrays blew off, and the ATM power system was able to contribute enough power to save Skylab while the rescue missions were being conceived. So there was a lot of intense and very creative activity to recover Skylab. The Skylab program was, well, the ATM program was all in-house, as I said, and it was really the last in-house program that Marshall NASA had. Okay, so at the end of the Skylab program, I was given responsibility for closing down the program, and we put together a number of very fine NASA publications on the results of the Skylab program that describe the program and all the elements of Skylab, which we did as sort of the last step of the program.
Well, and you sponsored a whole year of solar workshops that analyzed the solar data.
Absolutely, yeah.
And that was a real boon to the solar community.
Right, yeah. We were
You
very
did
much
it right.
We were very much involved with the science community, and that's one of the things I wanted to mention. Of course, in working the ATM, I became became acquainted with and had a lot of interfacing with some of the solar scientists, and they were just a pleasure to work with. They were all fine people that they knew exactly what they were doing, and they did a good job of coordinating with us at Marshall Space Flight Center.
The solar work done by the ATM, when the workshops were through, those books were the standard of what was known about the sun worldwide at that time.
That is correct. That
Was
a
very big accomplishment.
Right. So we finished up the Skylab program, and then the shuttle, in the meantime, the space shuttle had begun development. And of course, the space shuttle was built to carry various payloads, and turned out that quite a few of those payloads, of course, again, were science payloads, science-oriented payloads. So there was a carryover then from our experience on Skylab, and we were asked to manage a number of the payloads that were to fly on shuttle. And I became part of the Spacelab Payloads program, responsible for managing the science instruments and payloads efforts.
Who was in charge of that initially?
The initial person in charge of doing the payloads activity on shuttle was O.C. Jean. O.C. Jean, he was in charge for several years, and then Jim Downey, a fine individual who had earlier worked on the Space Telescope, came in and took the office over, and then after that it was I believe Sid Socher was the next manager in that area. Anyway, so I was given responsibility for managing the various payloads. For example, on Spacelab 1, there was a number of small science investigations inside the space lab, including microgravity materials experiments.
On the first shuttle flight, there was the induced environment contamination monitor.
That's right.
That's right. Almost the only real.
Well, I'm talking about Spacelab. I was talking about Spacelab 1, not Did I say Shuttle 1? I meant Spacelab 1.
Okay, Spacelab. All right.
Then Spacelab 2 was basically a solar science mission, a follow-on to the ATM. Spacelab 3 was largely technology, microgravity, and some science missions. Then there was an Astro mission, which was basically ultraviolet and X-ray astronomy research. And then another interesting payload was the large deployable solar array mission, or actually payload, which we flew on, I think the 47th shuttle flight, I believe it was. Anyway, it was a large solar array, the size that later was used on the space station, and it was to be deployed from the shuttle bay. And of course, you can imagine with this big thing hanging out there and possibly having a failure, what have you, there were an awful lot of safety questions that came up. Well, we worked away all of those, and we had a very successful deployment of that large solar array and demonstrated how well it could work, and that was very useful for the development of the space station. I guess the science payloads on shuttle continued on through shuttle flights, but most of these now were inside the space lab itself. We did mostly microgravity research, which required furnaces, and those furnaces were placed inside the Space Lab missions to do various materials processing experiments to show the effects of essentially zero gravity on materials and crystals and so forth. Then along came, actually it was a program that had been going on for a long time called all right, Francis Everett and the Stanford Gravity Probe B. Gravity Probe B.
Yeah, Gravity
Along
Probe
came
B.
Gravity Probe B, and it had been developing for a long time. It was an extremely challenging, technologically challenging payload, where a lot of inventions had to be made
The
in order for that thing.
hardest payload NASA ever took on.
I believe that's right. I believe it's right. You know, you had to have zero vacuum, zero magnetic field, zero acceleration, zero everything in
Yep.
order for these tiny
Gyroscope.
gyroscope, little
Quartz balls.
yeah, little quartz balls. They were kind of the size of a golf ball
Yeah.
to work for like a year or longer in order to measure to see if, in fact, the Earth's rotation twisted the gravity field, and to verify, by doing that, verifying that Einstein's theories about the effects of gravity and so forth were correct. Well, we worked with Stanford University on that, and they had Lockheed as a subcontractor and did a wonderful job on that thing. I mean, it was just amazing how they solved the various issues. Optical contacting in cryogenic environments for their telescope, that little pointy telescope that they had, and magnetic, eliminating magnetic effects inside the probe and so forth. It was just a marvelous thing. And fortunately, although I had already retired by this time, fortunately, the payload was launched and was launched successfully. And the results basically verified Einstein's theory, although the results, they had to do an awful lot of number crunching, because no matter how hard they tried, there were still little effects here and there. They tried to eliminate out of the results.
Yeah.
But after they did that, they basically concluded, and this was after a rather extensive science review, that yes, Einstein's theories were correct. Well,
You retired.
I retired before Gravity Probe B was launched.
When did you retire? What
This
year?
was in 1997.
97.
In 97, and I had no plans to continue to work, but after I'd been fully retired, I get a phone call and said, hey, we could use some of your help and experience from the various programs you've been in. And I thought about it, and I said, well, yeah, I suppose I could do that, but I don't want to do this full time. So I got back with the people and negotiated a half-time assignment, which
This was in Marshall again.
This was back with Marshall, as a contractor at Marshall, and my first assignment was back on microgravity furnace experiments, and then later on the Constellation mission on the Ares upper stage. I spent about 4 years on the Ares upper stage, for a total of about 12 or 13 years as a part-time support contractor for those activities.
Were you yourself the contractor, or were
No,
you
no,
part of
I
it?
was working for a number of different local
Okay, so
companies that had contracts with NASA.
so this wasn't a personal contract.
No, this was not a personal contract. I just became one of the
One of the supporting contractors.
Yeah, one of the supporting compers.
Yeah. Okay.
So I did that for another 12 years or so, and which was again a very interesting time. During that time, I of course could see very clearly how things had changed over the time, and as I mentioned earlier, where things were done rather quickly and rather efficiently, things have become less efficient because of all of the systems and all the desire to be perfect and all that kind of thing that have entered the way of doing the space business. And this may be true of not just the space business, but all business, I don't know. I've probably been rattling around a little bit too long.
No, not at all. You've covered exactly the things needed to be covered.
But yeah, 54 years out there has been just a really exciting ride, and I just couldn't have imagined a more satisfying career than I was fortunate in having had.
Are you still working?
Oh no, I 3 years ago I decided that that was long enough, and well, in addition to that, family situation was such that I really needed to spend more time at home and less time out there. So it was a fairly easy decision to then hang it up, even though I still like to take a drive out there
Yeah.
and see some of the people.
It's hard to let it all go, isn't it?
Yeah, one of the enjoyable things is to go back and meet some of the folks that used to work, not with, because all the ones I worked with are gone, but the ones that used to work for me.
Yes.
And
Yeah.
go out there and meet those people and see how they're doing. And then, of course, I have 3 children, and it turns out all 3 of my children are working out there at Marshall Space Flight
Really?
Center. Yeah. Yeah.
And that's almost a unique situation, isn't it?
Well, there've been quite a bit of.
Oh, there are other children, but all
other
3 of them.
All
that's-
3 of them, right?
That's
right.
pretty
And
unique.
2 of them, and in fact, it's not only the 3 children, but then also one of the daughter-in-laws.
Oh, really?
Is working there on the commercial program.
Well, that's very good. So
Yeah. So.
you've done your part to continue the mission.
Right now, I just hope that the space business will continue to develop into some new, exciting missions, so that they can have the same experience that I had.
Mhm.
And I think that summarizes pretty much what my 54 years have done.
Okay, well, at the end, we often ask what advice you have for the new generation. What facts learned, or what would you like to pass on?
Well, I've sort of mentioned it a little bit, that I think the new generation needs to go back and look real hard at some of the requirements and systems and methods of working that have entered the business. That are they really paying off in the results? Is the energy spent on these efforts really paying off on the results?
Mm-hmm.
Shouldn't just a little bit more risk be acceptable? The amount of reviewing and interfacing and working all these problems, what I almost feel is like to death, can be done more efficiently, I think. I think people, back in those days, I said, some individuals even, and I mean, anybody who has read about the Apollo missions knows how many really tough decisions were basically made by 1 or 2 individuals that completely changed the program. And they were not afraid to make those decisions. There seems to be an environment where people are reluctant to make those decisions today. And that needs to be changed, I think.
Are they reluctant, or just not given the authority?
Well, that could be a combination of that. Yeah. Of course, the new generation now has tools at their command that we couldn't even dream of back in the old days.
Yeah, in the beginning, we didn't even have computers.
No, I mean, everything was done on slide rules. That's
Yeah.
right. Now, with all this, and that's part of the problem actually that I'm mentioning, because there's so much capability there that's so easy to use, but all of that stuff that you use creates more work in the system. Yeah. The computer stuff just gets spread all over the place. The communication, everything. It's in some ways that's good, but it can also slow you down.
Yeah.
But that's my main thought.
Well, that's a good thought to leave with posterity. So thank you very much for coming in today, and we can end the interview at that point. Thank you again.
You're welcome.